This is problem 1-2 for mechanics, and here's the diagram. So the first part A asks calculate the total time from launch until the projectile hits the ground at point C. So what we should take into consideration here is at point C the object is at height 0, and which is the y final, and so we're going to be using this equation since we're only dealing in the height. And we're also going to only use the y component of the velocity. And so to find the y component of the velocity, we get 50, which is the velocity, the total velocity, multiplied by sine of 37, since this is the angle right here. And we get 30 meters per second. And then we plug it into the equation of right here. And so 30 meters for the velocity and 35 meters for the initial height, since we start right here. And 35. So 35 and plus 1/2, and you got the acceleration right here, and you solve it all out and you get time equals 7 seconds. So that's the answer of part A. And so for part B, it asks us to calculate the horizontal distance r that the projectile travels before it hits the ground. And so we can use the equation v equals d over t, and if you find for d, you get d equals vt. So that's what we're doing here, the x component of the velocity times time. And to find the x component of the velocity, you do 50 meters times cosine of 37, using the triangle right here. So this is cosine of 37, this is 50, and this is the x component right here. So you get cosine of 37, and you multiply it by the time, since to find distance you do v times t. So 50 meters per second times cosine of 37 times 7 seconds, and you get a distance of 280 meters. For part C, it says calculate the speed of the projectile motions at points A, B, and C. So at the velocity at A is just the x component of the velocity, which is 40 meters per second, and the velocity at B is equal to the initial velocity, which is 50 meters per second. And to find the velocity at C, we have to use the law of conservation of energy. And so at C, you can do 1/2 mv of c squared equals 1/2 mv naught squared plus mgh, and you get velocity at c equals the square root of v naught squared plus 2gh. And when you plug in the velocity at b and the velocity at a and acceleration acceleration of gravity, you get 56.6 meters per second for velocity of c. Moving on to part D, it asks us to calculate the distance x from C to E in case 2. So what we have to take into consideration is we have to use the center of mass formulas, and so pretty much x times 10 kilograms equals 30 meters times 6 kilograms, and you solve for x and you get 18 meters. And that's the answer for part D. And so going back to part C, the answer was 56.6 meters per second. B was r equals 280 meters, and for part A, t equals 7 seconds. And that is part.